Hello everyone, and welcome to this third example of our series, Identifying Unknown Substances for Paper 5, Alternative to Practice for IGCSE Chemistry for core and extended students. So, if you haven't seen the example 2 and 1, I invite you to watch them. We have more examples and more opportunities for you to practice. So, I'm gonna show you these exercises that we have here, so you can probably take some screenshots if you want to do it by yourself and then compare the answers. Okay, please remember that this paper is, or these exercises in this paper are very important because it's about 25% of the whole marks. Look, this is 10 marks in total and you have 40 marks. So let's get started. So for this exercise, we have solid E and solid F. We don't have aqueous solution in this one. For solid E, we're going to do many tests. So for test 1, we're going to gently heat half of the solid E in a boiling tube. And the observation is that a solution forms, steam is given off, and condensation forms at the top of the tube. So this is very basic. It says that a solution is formed, right? So how was the solution formed if we didn't add water? So probably the solid E is a salt or a mixture of salts, and probably this solid has water, right? So say that this is a salt and it has water, so it is hydrated. Why do I know that? Because steam is given off and condensation occurs at the top of the test tube, and this condensation is water. Okay, so my conclusion of test 1 is that we have water. For test 2, we dissolve the remaining solid E in water to form solution E. Okay, now we didn't have solutions here, but actually we're going to prepare a solution using the solid E. Then we are going to divide this solution E into 3 portions. So this is E1, then we have E2 and E3. Good. Now, it says that to the first portion of E, we're going to add aqueous sodium hydroxide. So we add NaOH, and we do it dropwise and then in excess. And the result for that is that a brown precipitate forms, which remains when excess of NaOH is added. So remember, when we add sodium hydroxide, we are always testing for cations. Remember that we have here a very specific part of the notes for qualitative analysis, and remember that you will provide it with these tables. So the aim of these videos is now for you to memorize this, but how you can use this information here, so it's not overwhelming for you when you take the paper. So we're going to add sodium hydroxide, and then we see that a brown precipitate is formed, and also we can see that when we add excess of this, it will remain the brown precipitate. So the only option that we have here, look, white precipitate, green, light blue, green, red, brown. Okay, here we have it. And look at this, insoluble in excess. So this is positive for iron 3 plus ions. So our conclusion of this test 2 is that the first portion, we are positive for Fe3 plus. Okay, that's our ion, our cation. Second one, what are the product of test 2 and test any gas produced? Okay, so let's see what happens. It says that the gas turns red litmus paper blue. Okay, and when we have this observation, like the only option that we have here is that look, we turn damn red litmus paper blue. So somehow we have ammonia. Let's look at it. Okay, what are the product of test 2 and test any gas produced? So remember, when we add sodium hydroxide and we warm up, we're going to produce ammonia. Okay, and then we test that ammonia. Okay, look at this, because ammonia is a gas. So this would be a little bit confusing here, because look, the product of test 2 is that you have like your solution, but now you have like NaOH, right? So since you have that, you warm it up and ammonia is produced. So you're positive also for ammonium ion. So wait, what? Do we have another ion? Yes. How do we know that? Because this gas that is produced, which is ammonia, it only comes from the ion ammonium. So this test 3 says, okay, you're positive for NH4+. And okay, wait, so do we have Fe3+ and also NH4+? Yes, it is possible, because it says solid E, right? But we have no idea what solid E is. It could be a mixture of salts. So it is a mixture of salts. So we could have different or many ions in one single sample. So my test is positive for ammonium and iron 3+. Test 4, to the second portion of solution E, so this is the second portion of solution E, we're going to add nitric acid and a few drops of aqueous silver nitrate. And always remember, when you have silver nitrate, that is a test for halides. Look, here we have the halides, and always nitric acid, nitric acid, nitric acid, silver nitrate, silver nitrate, silver nitrate. The only difference between the halides is that the test is different for each halide, the result. So for chloride ions, you have a white precipitate, for bromide, green precipitate, and for iodide, yellow precipitate. But look, what happens here? It says no change. So what can we conclude from test 4? We have no halides. Okay, so what about test 5? In test 5, we have a white precipitate, and this white precipitate is the result of adding nitric acid and barium nitrate. When you add nitric acid and barium, you are testing for sulfate ions. Look at this. So you come here, look, nitric acid and barium nitrate is always the same, and you have a white precipitate. So since this is positive, you can say that your anion for this sample is sulfate, SO4 2-, right? Okay, so please take into account that in order for you to learn and to have conclusion of all of these tests, and not even reading the questions, I'm just trying to solve this, but in real life, you should first read the questions. Okay, we are doing it just to practice, but for this, look at this. State what conclusion can be made about solid E from the observations in test 1. So what conclusion do you have from solid E from test 1? That the solid E is hydrated, or the solid E has water. Okay, so you can say solid E is hydrated. And look, identify the gas produced in test 3. Remember, the gas that turns red litmus paper blue is ammonia, and ammonia is NH3. Okay, so the gas is ammonia, or NH3. Okay. State what conclusion can be made about solid E from the observation in test 4. Well, we have it here, and the answer is we have no halides. Okay, or well, not we, but let's say solid A. Okay, A has no halides. Okay, and identify the 3 ions in solid E. Well, we already know that. Iron 3 plus, ammonia, NH4 plus, and the last one was the anion sulfate, SO4 2 minus. Remember, you can also put the names of these, like iron 3, ammonium, and sulfate. Very good. Look, 3 marks for identifying. Okay. And now, solids on tests on solid F. And you already know that solid F is zinc sulfide. So zinc sulfide is pretty simple. Zinc, and remember sulfide. Oh, no, I don't remember the sulfide ion. Don't worry. Look at this. You have all the ions here. So sulfide, sulfate, nitrate, whatever you need, you have it here. Remember that this is only available on paper 5. You won't have these tables on paper 4 and 3. Very good. So sulfide is SO3. Okay. And look at this, zinc. Okay, what about, you don't know the charge of zinc, but you have zinc here. So it's 2 plus. And sulfide is 2 minus. So this salt is correct like this. Okay. Student dissolve solid F in water to form solution F. And then you have 3 portions here. So F1, F2, and F3. And what we're going to do now is add aqueous ammonia dropwise until it is in excess. So to the first portion, what are we going to do here? Aqueous ammonia. So NH3, aqueous, and look at this. As you have sodium hydroxide, here you have effect of aqueous ammonia. So adding aqueous ammonia allows me to identify aqueous cations. And what are we gonna see? Since we have zinc sulfide, and we're testing cations, so remember our cation here plus is going to be zinc 2 plus, and our anion here is sulfide, which is 2 minus. So if we add ammonia, we are testing for this zinc 2 plus, and zinc 2 plus, look at this here. So what's going to happen? A white precipitate soluble in excess. Okay, so if we add just a few drops, we're having a white precipitate. But if we have excess, this precipitate becomes soluble and it is not white anymore. The solution becomes colorless. So let's see. The question is, observation adding drop wise? Well, pretty easy. White precipitate is formed. Observation in excess. The solid dissolves and the solution becomes colorless. Pretty simple. Okay, 2 marks. And it says to the second portion F of solution F, the student adds a few drops of acidified aqueous potassium manganate. So to this, a few drops of manganate. Okay, so we have already tested the cation, so let's try to test my anion. And to test my anion, look, we have here that if we add a small volume of acidified aqueous potassium manganate, the result is that the acidified aqueous potassium manganate changed color from purple to colorless. So in the very beginning, when we are adding this potassium manganate is going to be purple. But when we add and we mix that, the manganate ion is going to be reduced to Mn2 plus, and Mn2 plus is colorless. That's why it becomes colorless. So what are we gonna happen? What are we gonna see here? Very simple. That the purple solution becomes colorless. And why do we know that this is positive? Look, because this is the test for sulfite, and we know that our anion is sulfite, so of course it's positive. And then to the third portion, the student adds 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate. So it looks like it is a test for sulfate. Look, nitric acid with barium nitrate. But we do not have sulfate in our solution. We have sulfite. So since we don't have sulfate, we're negative for this test. So there's no change. We're not going to see anything when we add the reactants. So here, it remains the same, or you can say there is no change. Okay, and that's it. That's how you get 10 marks doing or identifying the ions in solutions or in noun compounds. And this is pretty simple. So if you have any questions, you can put it in the comments. If you haven't subscribed, please consider to subscribe, and I'll be uploading more videos in the future. Thank you so much for watching, and see you next time.